In this lesson, we begin looking at sequences. A sequence is a function A whose domain is the natural numbers 1, 2, 3, 4, etc. The value A of n is often written A sub n and is called the nth term of the sequence. Notation for a sequence A sub n, where n is greater than or equal to 1, or the set of A sub n from n equals 1 to infinity. We begin with an example. A sub n equals n plus 1 over n plus 2. We'll find the first four terms of this sequence. First, by finding a sub 1, where we set n equal to 1, we have 1 plus 1 over 1 plus 2, which is equal to 2/3. A sub 2, we set n equal to 2, and we have 2 plus 1 over 2 plus 2, or 3/4. A sub 3, setting n equal to 3, we have 3 plus 1 over 3 plus 2, or 4/5. A sub 4, we set n equal to 4, and we have 4 plus 1 over 4 plus 2, or 5/6. We write this sequence as 2/3, 3/4, 4/5, 5/6, ... Next, we have the set of -3 raised to the power n from n equals 1 to infinity. We'll find the first four terms of this sequence. The first is a sub 1, which is -3 raised to the power 1, or -3. The second, -3 raised to the power 2, with a sub 2, which is equal to 9. A sub 3 is -3 raised to the power 3, -27. And a sub 4 is -3 raised to the power of 4, which is 81. We write the sequence -3, 9, -27, 81, ... A recursively defined sequence. In this sequence, we're given the first term and a formula for finding remaining terms. To find a sub 2, we plug 2 in for n. We have 2 times a sub 2 minus 1 minus 2, which is equal to 2 times a sub 1 minus 2. We then replace the a sub 1 with 3. We'll have 2 times 3 minus 2, or a sub 2 is equal to 2. Next, to find a sub 3, we replace n with 3. We have a sub 3 equals 2 times a sub 2 minus 2. A sub 2 is 2, so a sub 3 will be equal to 2 times 2 minus 2, or 0. To find a sub 4, we replace n with 4, so a sub 4 is equal to 2 times a sub 3 minus 2, which is 2 times 0 minus 2. A sub 4 equals -4. The next recursively defined sequence, we're given the first two terms. A sub 1 is equal to 1, a sub 2 equals -2. A sub n for the remaining terms equals a sub n minus 1 times a sub n minus 2. So to find a sub 3, we set n equal to 3. A sub 3 will equal a sub 3 minus 1 times a sub 3 minus 2. So a sub 3 equals a sub 2 times a sub 1, which is -2 times 1. A sub 3 equals -2. We next find a sub 4, replacing n with 4. We have a sub 4 equals a sub 3 times a sub 2, which is -2 times -2. A sub 4 equals 4. Find an explicit formula for the nth term of the sequence, and here we have the sequence 1/2, 2/3, 3/4, 4/5. I get some help with this by writing n equals 1 below the first term, n equals 2 below the second term, n equals 3 below the third term, and then n equals 4 below the fourth term. And then I look at what I could do to these numbers to get each term, and it looks like if I plug in n value for the numerators, that works in each of these, and if I take the numerator plus 1, I get the denominator. So my formula for this sequence will be a sub n equals n over n plus 1. It looks like that works for each term here. Try on your own. Write out the first four terms of the recursively defined sequence. A sub 1 equals 1. A sub n equals n minus a sub n minus 1.